Hi Year 10 and welcome to video 2 for the duration of your quadratics topic. Well, I'm just going to cover things briefly, the rest of what you'll need to know in preparation for next week. Just keep in mind some of this is obviously new, but generally it's relying on the stuff that we have covered, and we're probably 85 to 90% covered. The rest of this is just linking those ideas together to make sure you can use them. The only really new aspect is the idea of solving equations using this kind of stuff. And the quadratic formula, which you will love. So first of all, we are going to be talking about solving equations, but I'd really like to just remind you of the three forms: standard form, and that's ax squared plus bx plus c, turning point form, and that is ax minus p squared plus q, and of course zeros form, factored form or something like that, and that is ax minus alpha x minus beta. Now the reason why I brought this up is just a little bit of an addition to what we've talked about prior to this on these three forms. I'd like to make that really clear with you. So just in red here, now that we've talked about last lesson, we can go between these three forms at will. So first of all, if we're heading from turning point form to standard form, we just expand brackets, and that's what I did right at the start of last lesson. If we're heading from zeros to standard form, well, we just expand brackets again. Then, if you're heading from standard form to turning point form, this is where we completed the square. That will help you do that. And if you're going from standard form to zeros form, well, this is where we factorize. And that leaves one section. And unfortunately, it is quite difficult to move from zeros form to turning point form, or turning point form to zeros form. What you need to do to get from turning point form to zeros form is you follow the line to standard form, and then you follow the line to factored form. So to go from turning point form to zeros form, you expand into standard form, then you factorize. And the same way, if you go from turning point to standard form, you expand into standard form. So zeros form to turning point form, you expand into standard form, and then you complete the square to get into turning point form. And this means that whatever format your function is in, your quadratic function, if you need to know the turning point, you can get there. Spread it right out to standard form, whatever format it's in, and then complete the square. If you need to know the zeros, you can get there. All you have to do is bring it back into standard form from wherever it is by expanding and simplifying, and then factorize. You're there, okay? The only extra note, or the only extra two notes I'd say to this, is first of all, factorizing doesn't always work. It's not always that easy. It will always work, but sometimes you're dealing with difficult fractions or irrational numbers, so factorizing can be hard. So we're going to show you a trick in a moment called the quadratic formula, which will help you factorize if it gets a bit too hard. But then on the other hand, we're not expecting you to do anything majorly out there in the exam. There will be, like I say, non-routine or complex questions, but not irrational or difficult fractions in factorizing. So don't expect that. You can expect simple factorizing questions and very doable factorizing questions. The second thing I'd like to say is the zeros form is really important, because the zeros form tells you what we call the zeros, or the roots. So if you've got a quadratic function like this, there it is. This quadratic function has a turning point, and that turning point is at P, Q. So you knew that already. That's turning point form. Zeros form actually represents the two x values. It's magic. These two x values here. That one's alpha, that one's beta, or the other way around. Okay? Whatever quadratic you got, if it crosses the x-axis, it can be factorized, and there your alpha and beta. It's when, as I was saying before, alpha and beta are difficult values, irrational or long decimals, that you might have actual trouble factorizing it into zeros form. If you have your function in standard form, then that will actually give you your value here, which is your C value. And your C value, I'll circle up the top here, your C value is your y-intercept. So your zeros form gives you your x-intercepts. Your turning point form gives you obviously your turning point. And your standard form gives you your y-intercept. There's only one y-intercept in this case. And of course, in each form, you get that A value, which is the same for all three. And that's your dilation factor, which basically tells you how steep your quadratic is. So there's some good information for you when it comes to dealing with our moving between forms and why we do it and what we're actually calculating. So now we're going to talk about solving quadratic equations. And this is really important, but we haven't really managed to get into it as deep as we would like to. So the depth of the questions in your exam are reflective of what you will have learned. Solving quadratics. So we've played with a lot of quadratic functions, y equals a quadratic in terms of x, or just with quadratic terms, something like ax squared plus bx plus c. What we haven't done is solve any equations, and an equation you might recall is a solvable function where there's only one variable that's unknown. So let me just give you an example, and we're going to do this one by factorizing. Okay, so we have an equation, let's say x squared plus 8x plus 12 equals 0. Okay, so x squared plus 8x plus 12 equals 0. Now, this has become now an equation because it's not equal to y, it's equal to 0, which means that there's some values of x that will solve this. And those values of x will actually represent our alpha and beta. So first we factorize. Now, you recall that we do our little factorization over here. We add two numbers to get 12, sorry, that's wrong, to get 8. And we multiply two numbers to get 12. And those two numbers, I hope you can see, are 2 and 6. I've made this one pretty simple. Which means we have x plus 2 times x plus 6 equals 0. Now here comes the magic bit. I'm going to do this in red. It's the in-between bit, and we'll talk about this next week anyway. You've got two numbers, okay? I'll call them number 1 and number 2. These are two numbers. Whatever x is, x might be 10, in which case the two numbers are 12 and 16. X might be 100. X might be negative 5. Whatever x is, they are two numbers. Those two numbers, when multiplied together, equal 0. It's really important to recognize what that actually means. Mathematically, if two numbers multiply together to equal 0, it's implying to you that one of those numbers must be 0. If you can find for me an example of any two numbers that multiply to give 0 where at least one of them is not 0, please come and tell me, and I'll quit my job and you can have it. That would be super. In the meantime though, you're going to have to deal, unless you can prove me wrong, you'll have to deal with the fact that two numbers multiplying together equals 0, one of them has to be 0. Okay? So it implies mathematically that either n1 equals 0 or n2 equals 0. So this is our little in-between bit. And back in black pen, I hope you can now see that the implication can also be used for our equation. If x plus 2 times x plus 6 equals 0, then x plus 2 equals 0 or x plus 6 equals 0. And that means that x equals negative 2 or x equals negative 6. And we've solved those equations. We've found the two solutions that make this work. Shall we just verify very quickly? Let's do a quick verification. If x equals negative 2, we get this. Negative 2 squared plus 8 times negative 2 plus 12. And that equals 4, because a negative number squared is a positive, minus 16 plus 12, which equals 0. Works. What about x equals negative 6? Negative 6 squared plus 8 times negative 6 plus 12 equals, can't jump to there yet, that equals, and I should have brackets around the negative 6, 36 minus 48 plus 12, which equals 0. Okay, but hold on a second, maybe just any number works. Let's try this. X equals negative 5. That gives me negative 5 squared plus 8 times negative 5 plus 12 equals 25 plus, not plus, minus 40 plus 12. That equals negative 3. Doesn't equal 0. So I'm telling you now that these are the only two answers that work. X equals negative 2 or X equals negative 6. A linear equation has one solution. A quadratic equation has two solutions. Not always. There are special cases where it doesn't, and we'll talk about that. But for now, take it for word that a quadratic equation has two solutions. Another example, by factorizing. Okay, x squared minus 10x plus 24 equals 0. And that gives me this. Two numbers that add to give negative 10, multiply to give 24. Those two numbers, 24 is positive, so they're either both positive or both negative. Negative 10 is negative, so they must both be negative to add to a negative number. I'm looking for two numbers that multiply to give 24. 6 and 4 work really well because they also add to give negative 10. X minus 6, x minus 4 equals 0. And therefore x minus 6 equals 0, or x minus 4 equals 0. Okay, because two numbers multiply to give 0, one of them must be 0. And that means that x equals 6 or x equals 4. Done. Easy. No problems, I hear you say. Two solutions, that's what you're expecting at this stage. Now you might remember earlier that we talked about the fact that alpha and beta, our two values in standard form, in zeros form, are actually our x-intercepts. So that implies that the function here will look like this. It'll go through 4 and 6, and it's a positive quadratic, so it will look something like this. There it is. So we've already know heaps about our function. Okay, our function in standard form had plus 24, so somewhere up here at 24 is the y-intercept. We know that as well. So we've got a lot of information already about our function, just from factorising and finding the zeros. If you completed the square on the standard form function, you'd be able to get the turning point as well, which I suspect, due to symmetry, and I say suspect, really I know, that it will have an x value of 5. Magic. Okay, so that's factorising to solve an equation. You need to know about that. And there's some practice questions on that in, I believe, 8.2, but you'll have to have a look at the titles for me. Secondly, completing the square to solve an equation, a quadratic equation. Same thing again, it doesn't matter what the quadratic equation is, you can complete the square to solve it. Even if it can be factorised, you can still complete the square. The magic thing about completing the square is typically factorising will be easy if you've got some nice easy numbers. Completing the square will always work. Even if you've got difficult numbers, it's not a big ask for you to be able to do it. That's the magic about completing the square. So we can complete the square by doing this. Let's say that we wanted to solve the equation x squared plus 8x minus 2 is equal to 0. Okay, so we complete the square. First of all, we have x squared plus 8x, well left gap, minus 2 equals 0. Change of pen colour. It's what we did every time. Get that 8, halve it, it's 4. Square it, add it on. Halve it, square it, add it on. Repeat after me. Halve it, square it, add it on. X squared minus 8x plus 16, and then we subtract that extra 16 to make sure that it works. put some brackets around here just to make sure that we're doing all these things together. And now we have x plus 4 squared, and minus 16 minus 2 is minus 18 equals 0. Now, unlike before we had two terms that had x in it, made it really hard to solve, we actually now have a situation where we have just one x term here. So it's just made the equation, rearrange it to make it easier. So now I add 18 to both sides. This gives me x plus 4 squared equals 18. And then I take a square root. And when I take a square root, here's an important factor. So I get x plus 4 equals the square root of 18. But remember, when I square root a number, it could have come from a positive thing squared or a negative thing squared. So I get the square root of 18 plus or minus, and this plus or minus is pretty important here. That's where our two answers come from. Then I subtract 4, and I get x equals negative 4 plus or minus the square root of 18. Now, I am clutching around very quickly for some sort of calculator because this is going to be an irrational answer, and I don't have a calculator. So unfortunately on this video, I'm not actually going to give you the answer to this question. But I can tell you that the answer is going to be somewhere around about, it's negative 4 plus the square root of 18. The square root of 18 is slightly more than 4. So negative 4 plus something slightly more than 4 is going to be about 0. And I'm just going to have a guess and say about 0.2. Or negative 4 minus the square root of 18. I might actually just write this extra line. I might just write negative 4 plus the square root of 18. Or negative 4 minus the square root of 18. And it's going to equal approximately 0.2 or negative 8.2. One of those two answers. But it's going to be irrational. The square root of 18 is an irrational number. Unfortunately, that's going to make our lives just a touch difficult. Just keep that in mind. And think about this question. You could have had to go at factorising that. That would have been fun. But obviously, you would have had very little chance. I would have had very little chance. Most people have very little chance of coming up with the answer negative 4 plus the square root of 18 and negative 4 minus the square root of 18. That's pretty tough. So, there it is. Completing the square to solve an equation. And that's all you need to know on that. Go through, practice some of those, look at the examples, ask your teacher. We'll talk about it a bit more. And the last one is using the quadratic formula. Okay, so here's the quadratic formula. I'm going to write it down. It's going to be pretty big. If you are in standard form, if ax squared plus bx plus c equals 0, so make sure you've expanded all brackets, you've got the terms in the right order, even if a is negative, or if a is 1, b is negative, c is negative, whatever, I don't care, they're in the order something x squared plus something plus something, plus something x plus something equals 0, then you need to go and make sure that you use this formula as an option. This is a really good formula to use as an option. Okay, so here it is. And remember, this is called a generalization because A, B, and C could be anything. So this represents every quadratic. You can do every quadratic using this method. Quadratic formula. X equals negative B plus or minus the square root of 4A, square root of B squared minus 4AC, got that wrong there, over 2A. So you need to know what A is equal to, what B is equal to, and what C is equal to, and then just substitute them straight into that formula. Now let's have a look at an interesting couple of examples. Let's start with the example we did earlier on completing the square. So this example just here, x squared plus 8x minus 2. Let's say we're doing x squared plus 8x minus 2 equals 0. Then we would have this quadratic formula. X equals, over here, A equals 1, B equals 8, C equals negative 2. X equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 2. So I'm just substituting in A, B, and C as appropriate. 2 times 1. Okay, so my B's are here and here to match my B's up here and here. My A's are here and here to match my A's up the top. And my C is there, and I've done my substitution there. And now I just simplify this. At this stage, you could put this almost straight into your calculator. -8 plus or minus the square root of 8 squared is 64, minus 4 times 1 is 4 times -2 is -8, all over 2, and that equals -8 over 2. I'm going to separate the fraction now, plus or minus the square root of 72 over 2. Not quite what we're looking for yet, but this equals -4, and you're going to have to trust me just a little bit. You'll obviously have a calculator to do this, but the square root of 72 divided by 2 happens to equal the square root of 18. If you don't trust me, do it on your calculator. I tell you it's true. And look at this. There are our two answers for x. And, oh wow, they were our two answers for x earlier. Quadratic formula will work every time, simplifying the question. Right now you might be hating me because I didn't tell you this earlier. We've been factorising, completing the square, what might seem for nothing, but the quadratic formula comes from completing the square. And so you need to know, well, we needed to know as mathematicians how to complete the square before we could develop the quadratic formula, which is a generalisation of completing the square. You'll notice after this video there's one more video where I'm actually going to talk about where completing the square, how completing the square gives you the quadratic formula. And that'll be a quick video for any of you who are interested. I'll do one more, and I'll do one more of our examples of factorising. X squared minus 10x plus 24. It's going to be quite large, but we'll do it. B, x squared minus 10x plus 24 equals 0. A equals 1, B equals -10, C equals 24. So we have x equals -10, so negative of b, which is -10, plus or minus the square root of -10 squared minus 4 times 1 times 24, all over 2 times 1. So I've done my substitutions there. Simplify. -10 just becomes +10. Plus or minus 100 minus 96. I'll tell you that's true. You can check it on your calculator if you want. You'll have a calculator. 2. 10 divided by 2 equals 5. Plus or minus the square root of 4 over 2. And that equals 5 plus or minus, the square root of 4 is 2, divided by 2 is 1. 5 plus or minus 1. So it equals 5 plus 1 or 5 minus 1. 6 or 4. There's our two answers. Shall we go back up and check? Going back up, going back up, going back. What did we get? No, not that one. This one here. Oh, well, 6 and 4. Magic. Isn't maths fun? So there's my last example of using the quadratic formula. The only other thing I really want to mention to you is that you should be looking for links and connections between things. And I want to show you one little connection. Notice here that 5. It's a bit magic. And if I go back up to the top, to, well, not quite the top, but to this example here, where we found x equals 6 and x equals 4 were our two x-intercepts by factorising, and I suggested that 5 is almost certainly our turning point because of the symmetry in quadratics. Turning point exists at 5. Well, that 5's come up naturally down here. It's come up there, and it's come up because of this part of the quadratic formula. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac over 2a. If I split this fraction up, I get this, -b over 2a plus or minus square root of b squared minus 4ac over 2a. Just split the top in half. Make sure they're still both divided by 2a. Notice here, this is like our starting point. This is where we start. And then this value here, which is, believe it or not, it's just a number. Might be horrible, might be really nice. It was 1 earlier. That was nice. It's just a number plus or minus another number. Okay? This is like the center of our quadratic. And then to get our two zeros, we go above or beyond. Let me show you that diagrammatically. So here's a quadratic. Just some random quadratic. I haven't defined it. It happens to be positive, but doesn't really matter. The center of our quadratic's right here. There's our turning point. TP is at P, Q. So we know that for a fact. Then we have our zeros here. Now I'm going to tell you right now that actually the turning point exists at negative b over 2a, comma q. And I'll talk about how to find q in a minute. Right here. And we get that negative b over 2a, and we add, so we'll zoom in a little bit, we add the square root of b squared minus 4ac, all that horrible stuff, over 2a to it, and we get our first root, which we call alpha. Or we subtract b squared minus 4ac over 2a, and we get our second root, which we're calling beta. So you start at the center, negative b over 2a, which is here, and you add or subtract the second part, b squared over minus 4ac square root of over 2a, and that will give us our two roots. So the turning point, the theme, the idea, the final principle I want you to get is that the turning point x value is always at negative b over 2a, where the quadratic is ax squared plus bx plus c equals y. So we're talking about a function again here. That's always a turning point. If we want to find our y value, we work out what this is equal to. So some number. Don't forget it always equals a number. And then y is equal to a times some number, whatever that number is, squared plus b times some number plus c. Magic. All you do is you substitute in your x value, the turning point, back into the function, gives you your y value, ba-boom, you've got your turning point. So we can use the quadratic formula to get the turning point. Magic. We can use the quadratic formula to get our roots. Magic. We can factorize to get our roots. We can complete the square to get the turning point. We can expand to get back into standard form. We can get all this information by doing a whole bunch of different things. Right now, if you're preparing for your exam and exam block, the best thing you can do first of all is get your mind sorted and understand the different features of quadratics and how they link. If you've got those links down pat, you will be fine. Absolutely. Don't forget, speak to your teacher if you need to. Thank you.